And what questions? Like some so you can follow along.
I have this.
Oh, yeah, that with you. No questions off the packet? Forgot to check everybody's calculator too, but I'm having faith that, Josh, do you have a calculator?
Yeah.
Is he lying to me? Is it gonna do you good hiding in your bag?
For the rest of class.
There you go. Doesn't do any good hiding in your bag. Other questions? None?
12 on the front.
12 on the front?
Of the packet?
Yep. Problem 12 on the packet says the perimeter of an equilateral triangle is 60 meters. Couple of key things that you got to remember. One of them, let's go back over this real quick. If you have a square, because they're going to start you off with these two shapes a lot of times, because there's a lot of different information you know about them. If you have a square and you draw in a diagonal, what kind of triangles are formed?
45, 45.
Very good. 45, 45, 90 triangles. Right? Both of them are 45, 45, 90 triangles. If you have an equilateral triangle, what do you know about this angle right here? How about this angle?
60.
And I'm not even going to fill in the other one. Well, we can, it doesn't matter. Fill it in. All of them are 60. It says the perimeter of the equilateral triangle is 60, so this perimeter is 60. Don't get this 60 confused with the other 60s. They don't have anything to do with each other. Find the length of an altitude. Well, if I draw in an altitude, what's an altitude do in a triangle? Goes from vertex to the
Median.
wow.
How altitude goes down, form a 45-degree angle at the next line.
Right angle.
Mine.
Yeah, whatever.
All right. So when we do that,
I was ready for a math test.
two triangles are formed. What kind of triangles are those two triangles? 30, 60, 90 triangles. So not only does this come down here and it forms a right angle, what's it do to this angle up here? Bisects it, very good. What do you think it does to this side over here? Bisects it. So we have this triangle, 60, that's 30. In a 30, 60, 90 triangle, how do we label the sides?
We know that the hypotenuse is 30.
All right, so let's do this first, Peyton. Across from the 30 is L, across from the 60.
is L.
Very good. And across from the right angle? 2 times L. Right? Make sure you remember that when you're labeling a 30, 60, 90, 45, 45, 90, or when you're doing sine, cosine, and tangent, you're labeling all three different ways. So don't forget how you're doing each one. Now, Peyton, they told us that the perimeter was 60, so what do we
We
know?
know that each side would be 20, so the hypotenuse is 20.
So this over here is 20.
Which means L is 20.
So we set up that equation. Now I know it's not too hard. Most of you can probably say, why am I setting up this equation? But just to make sure you understand it. So you set the part you wrote down, the part they told you, you just take those two parts and set them equal to each other. And Peyton's already told us that, what's L?
10.
If L is 10, how long is this part right here? 10. They wanted to know the length of the altitude. This is actually going to be our answer for this problem. Well, if L is 10, what can we stick in there? 10, and it's 10 square root of 3. So that would be your answer. This is the one that they actually wanted for the answer. 10 radical 3.
Yeah, it's squirting and I don't remember how to do. It's on the front page.
Number 8 on the front page. So right angle, 60 degrees, 30 degrees. So what kind of triangle do we have here?
30, 69.
Side across from the 30-degree angle should be labeled what?
L.
Side across from the 60-degree angle?
L times the funky line 3.
Side across from the right angle?
2 times
They told us little b was 15. Well, where's little b?
L.
Across from which letter?
B.
Across from big B, right? So that'd be here. So that's 15. What's our equation that we have to set up? This is the harder ones. Now, two different ways you could do this. I'm going to do it both ways. Have a calculator to help me here in a second. If you're solving for L, how do you get L by itself?
Square root of
Remove the red.
Divide, right?
5.
Don't let it confuse you just because it looks different. If I put this up here, L times 4 equals 26. What do you do to get rid of the 4 there? Divide both sides by 4. It's the same if it's radical 3. It's the same if it's 0.4628, no matter what, all right? So, we divide both sides by the square root of 3. Here's where you have to be careful. Especially something like here, next week you're going to take the map test and it's multiple choice. Well, if it's a multiple choice answer and you grab your calculator and you change it to decimal form, does that mean they put the answers as a decimal form? No. But they may. So somebody tell me what is 15 divided by square root of 3 if we want our answer as a decimal.
8.66.
8.7 maybe then?
Yeah.
All right, so that's the decimal form. Remember, that's the rounded off form. If they want the exact form, then we got to do this process. Can't leave the radical in the denominator, even though, again, I have seen on the OGT test before where they left the radical in the denominator, and that's not supposed to be mathematically correct. You multiply the top and the bottom by whatever that radical is. On top, you can't multiply those together, so you just put 15 radical 3. On bottom, what is 3 times 3? 9, what is the square root of 9? 3. That's the whole purpose. Is there a radical in the denominator anymore? No, it's gone. Now that's not quite our answer yet because we can reduce those regular numbers, the 15 and the 3. How many times will 3 go into 15? So then you got 5 times radical 3. That's your exact answer. This would be the rounded off answer. Sometimes they'll want one answer, sometimes they'll want the other one. You just got to figure out which one they want. If you want the exact answer or if you want the rounded off answer. Number 11, you're preparing to land an airplane. Your straight line approach has an angle of depression of 3 degrees. What is the straight line distance to the runway when the plane is at an altitude of 500 feet? So we got this airplane. I'm not drawing the picture this time, so you can't laugh at my
I
art.
just drew triangles. I didn't know.
Right,
Sure,
that's
really
good.
cool airplane.
That, see
It's a
it?
UFO. We'll just go with that.
This is my airplane. The runway's down here somewhere. The airplane's looking down at it. Oops, went a little too far. This angle right here is called the angle of what? Depression. They told us it was 3 degrees, so we'll stick that in there. My angle sure doesn't look like a 3-degree angle, but because that'd be a really small angle, right? Is it normal for an airplane 3 degrees? Let's say an airplane was taken off. If the airplane's taken off, is this going to be like a 57-degree angle?
No.
No.
12 degrees nose up pitch.
All right. If you get higher than 15 degrees going up,
You'll stall.
yeah, it's not a good thing. All right. So whenever you're dealing with aircrafts, they're going up very, very slow. Usually, like a big jet plane that people fly on, 4 or 5 degrees is all they go up. and that's going up fairly quick. All right, they start going up more than 4 or 5 degrees, then the people sitting in there,
I don't know, it seems at first when you take off, it's kind of a lot, but it's really not.
it's not, well, and it's not because of the angle, it's more because of the pressure. All right, so we got a 3-degree angle there. Let's see, what else did they tell us? The plane is at an altitude of 500 feet, so over here it's 500 feet off the ground. Well, that 500 feet doesn't fit in our triangle because it's over here. But what do you know about this distance here as it relates to this distance over here? If I draw this, what kind of shape is that going to end up being? Rectangle. And if this is 500, what do you know about this distance? It's 500. You could have said the same thing if there's, a person standing down here on the runway. Their angle elevation looking up at the plane would be 3 degrees, and you could have used this triangle. But let's get rid of that. So now we just have that triangle. That's a right angle. What do they want to know? The straight line distance from the runway. Again, I'm not real happy with the idea that people ever use the phrase straight line, but because if it's a line, what do you know about it?
It's straight.
Straight.
There's
That's,
a curvy one.
there is no such thing as a
I know, I
curvy.
remember you saying that.
So, but when you're doing something like this, straight line distance, is that, and we're going to call that X because we don't know what it is, so that's going to tell the pilot how far he is from the runway. Are we going to use 30, 60, 90 or 45, 45, 90 on this triangle? No. So we have to use sine, cosine, and tangent. Which angle are we going to deal with? Now watch carefully because this is the part where everybody has the most trouble. Most of these problems aren't that difficult as far as the math goes. Where people have the most trouble is looking at it and saying, well, I don't know which trig ratio to use. The way you decide which trig ratio to use is you label your triangle, and then that tells you the parts you want to deal with, and that leads you to your trig ratio. What's that 500 going to be labeled? That's the opposite leg, good. The X over here is going to be labeled the, good. And then this other side is the, do we care, which one don't we care about this time? So we care about the hypotenuse and the opposite. Well, in SOHCAHTOA, just a second to write it. In SOHCAHTOA, which one deals with the opposite and the hypotenuse? Did I say opposite and adjacent a second ago? Opposite and hypotenuse. Sine. So we're going to use the sine this time. When you set up your equation, you set up sine, it's always the trig ratio, then your angle. Well, what's our angle this time? So trig ratio, angle equals, and then always your fraction. What over what this time?
500 over X.
500 over X, good. Put a 1 under this to make it a proportion. What do we do next? Find the sine of 3. Don't hit second button. Only hit second button if you're looking for an angle. Just hit sine 3 degrees. That gives you some decimal.
0.0523.
523, is that right?
Yep.
Over 1 equals, why my pen not working all of a sudden? Now what do we do?
Cross multiply.
I'll do the hard part for you. 1 times 500 is 500. What do I write down on the other side?
0.0523 X.
Oops, 0.523x. This is what I was talking about a little while ago when we had the radical. Had somebody in first block again. We did a problem just like this, and most of them are all basically the same problems, right? Problem just like this, and they want to divide both sides by 500. Right? Don't let it confuse you just because you put a crazy decimal or a radical or something else in there. You always divide by the number that's with the what? The X, the variable. So divide both sides by 0.0523. what should happen to 500 when you divide by a number like,
Go up.
it should get a lot bigger. So anybody, can you sort of think in your head, because you guys are intelligent enough. What if I was dividing by something like this, 0.1127? About how much bigger is this top number going to get?
10 times.
About 10 times, all right? Because it's 0.1, and 0.1 is a tenth. So whenever I look at this, you can sort of get some idea what your answer should be about, all right? Well, this is 5/100ths, okay? So I know instead of being like half as much, it's going to go up probably about, what, 20 times as much?
Yeah, it's about right.
All right? So, because 0.05, that's a 20th of a dollar, a nickel's a 20th of a dollar. So I know that this number should get up to be about 20 times bigger. Now, do I expect you to remember every bit of that? No. But when you're dividing by something like this, or you're dividing by something by like 0.5, what's going to happen to your number if you're dividing by 0.5? It gets twice as big, all right? Because that's half of one whole, so it doubles. If you can remember stuff like that, then you'll know when you get an answer if it makes sense or not. What's X come out to be in this case?
9,560.
What was that, feet or meters? Feet. So it makes sense for that airplane to be 9,560 feet off the runway?
Yeah, that makes sense.
We hope that the pilot starts looking at least that far out, right? That might even be a little close. I'm hoping,
It's like 2 miles away.
I'm hoping that, yeah, I guess 2 miles.
2 miles out of 500 feet. It's not bad, but-
Yeah, he might be flying a little low at that point. Let's hope it's a small airplane, not some great big
The
key.
sonic barrier just need to break their windows. Might knock them out though. No, it doesn't. It like knocks them out of their frame.
Problem 14 on this back of that page. You're in a hot air balloon that is 600 feet in the air looking down at a friend that is taking your pictures. Everybody knows that I'm probably not the world's greatest reader. Your friend is 1,000 feet from the point directly under the balloon. What is the angle of depression from you to your friend? I'm not drawing the picture. This is you. You're in the hot air balloon. Your friend's right here. So friend, you. There's some point right down here, directly under the hot air balloon. Goes straight down to that, straight over to your friend on the ground. We know that forms a right angle. And they tell us that you are 600 feet up in the air. Your friend is 1,000 feet from that point. I'm sure Faith drew us a pretty little picture, right? With the hot air balloon, and it's probably got colors in it and everything, and oh, it's just a triangle.
Mine is,
I drew a picture, but I
Yours
didn't
is pretty,
draw it.
Brian?
Sorry.
mine is black and white.
Oh, you didn't color it in for me? You didn't make the hot air balloon and with the strings and
That's a tree.
everything, and
That's a good tree.
Oh, it has a hot air balloon and a tree.
but you didn't put anything on it, like little checkers or something to color it in and make it all pretty for me?
It looks like a ninja.
And they tell her, we're trying to find, what, your angle of depression? Yeah. So we're trying to find that angle of depression right there. So we're going to deal with this angle. Side across from that angle is going to be labeled what?
Opposite.
Side across from the right angle.
Hypotenuse.
Side across, or I'm sorry, the side that hooked to the angle. Adjacent. Which one don't we care about this time?
Hypotenuse.
Hypotenuse. Which trig ratio deals with opposite and adjacent?
Toa.
The TOA. So what is it? It's the TOA part, so it's the tangent. So tangent of, what's our angle?
X. Over 1.
Equals, what is it?
1,000 over 600.
And Brighton's already ahead of me, because he said put this over 1, right? Now, the bad thing is this time,
Negative variable units.
I listened to Brighton.
Wait, isn't that 10 over 6?
Is it the other way around?
Opposite over adjacent.
Opposite over adjacent?
I mean, can't we like make it easy and go 10
Oh,
over?
could you reduce it? Yeah, you could.
Come on, come on, Emma.
You could, so you could get rid of, Peyton saying you could get rid of 2 of the zeros on the end of each one of those to make it a little easier to punch into your calculator. What do you have to, since we're looking for an angle, what do you have to hit first on your calculator? Second.
Okay, wait, I'm confused.
Mine's 10 divided by 6.
I never know.
Right, you gotta do something different. So second is like your third or fourth button, right?
Yep.
Okay, so then you're finding this.
What are we doing?
It's a scientific calculator.
Oh, I guess
To-
you.
It just doesn't print across the screen. Some of these calculators all print across, those don't. That's the only difference in them, but
What's it do?
it does everything backwards.
Reduces it by 3.
Do what? Yeah, that's true. But I don't like it.
Lightweight and efficient.
So what is x? Hit second, tangent, 10 divided by 6, what do you get as your angle?
59.
5, 9.
59 degrees. Does that make sense for an angle?
Yeah.
What, to help you out, all the angles that we're doing in any of these problems,
I usually around 30, 45.
all right, so if you get something like this for an angle in a problem in here, do you think that's right? No, probably what you did is you hit
10.
like second tangent and then punched in 10 divided by 6. No, hold on. I said that wrong.
That's not right.
I,
That's the right way.
I said it the right way. So if you didn't hit second and you just hit tangent of 10 divided by 6, and it gives you something like 0.029097, and that's supposed to be your angle, then you know you messed up somewhere. All right? So whenever you're getting an angle, my whole point here is, make sure it's not too small. Make sure it's not some crazy angle that we've never dealt with. So I would say anything that's higher than 1 degree, it's possible for some. We just got done dealing with one that was 3 degrees a second ago. And what's the highest it could possibly go up to? 89 degrees. If you get up past 90,
Then that-
it doesn't work because all of the triangles that we're dealing with are what kind of triangles? Right triangles, so these other 2 angles can't be 90 or higher. So you could check yourself just to make sure. Now, does that mean just because you got 59 degrees that it's exactly right? No, but it's not a silly answer. All right, it's not just some ridiculous answer that I'm going to look at and say, what in the world? And then probably come back to you and say, all right, Austin, how in the world have we ever dealt with an angle like that? And
It would
again,
be awesome.
make sure your calculators are working right. I had to fix somebody's yesterday, and it took me forever because they had a different kind of calculator, and I'd never used it before. They were doing problems like this, and when they would get their angle, the angle it was getting was something like that. And we weren't doing the problem wrong. It was just in the wrong setup. All right, so it was measuring the angle, but it was measuring the angle in radians, and we didn't want radians in 1 degrees. I had to call Texas Instrument to. But it will now once it's
Blue screens.
Problem 9 on the front of that worksheet. Probably after this one, this will probably be the last one. It says solve each triangle. So as we solve this triangle, all it means when you're solving a triangle is find all 3 sides, all 3 angles.
Really?
All right? So when you're solving it, you got to know all 6 parts when you're finished. What's the easiest part to find first?
The last angle.
The last angle. So how would we go about finding that last angle?
90 minus 28.9.
So somebody help me out on their calculator. 61.1.
Oh, I can do that.
So we'll write that in there. So So that's one of our answers, 61.1 degrees. Now we gotta find how many sides?
2.
Two, we know one of them. Now, just because this is 13, does that mean this is a 5, 12, 13
No,
triangle?
because that's how I got it.
All right, that'd have to be the hypotenuse, so it doesn't work out in this case, so you can't just throw that in. So what we gotta do is use sine, cosine, or tangent. Here's another bad thing, because when you start letting teenagers make choices, they seem to get confused. What are you laughing about, Weston? You knew what I was gonna say, didn't you? Because you probably made some.
I know the future.
I have only made good
Which-
choices in my life.
Which,
He's the only good joke. Come on.
which angle are we gonna deal with here? I'm not even gonna. All right, so if we deal with this one,
First.
it doesn't matter which one you deal with. It doesn't make any difference. You could use either one. Your answer should come out the same. We deal with that angle. What's this side over here gonna be labeled?
Opposite.
This side?
Hypotenuse.
Hypotenuse.
You just instantly go to write the adjacent, and then you instantly back away from
No.
it. No.
Well, because when I do it myself, I always do opposite, adjacent, and hypotenuse. But for most students, I think it's easier to, adjacent's the hardest one to figure out normally because, and probably not for you, Brighton, I understand that. But I do opposite because I can draw that arrow. I do hypotenuse because it's always across from the right angle. Then the third one has to be
So
the
whatever
adjacent.
my pencil's closest to, I don't know if I can move my hand much.
And seeing that it shouldn't, that's the way I am. It shouldn't, if I'm writing, I'm just gonna write it. But since I gotta explain it to all these different students, I usually try to do it the way it's gonna try to be the easiest for them. Which side do you wanna try to find first? Adjacent. So we'll call this X this time. So we care about those two. How come I don't care about the hypotenuse this time?
Because you're gonna find that.
Not needed.
All right, it's not needed for right now, right? Now, we do need it,
Yes.
but for right now,
No.
all we care about are these two. Which trig ratio deals with opposite and adjacent? So we set up our equation, tangent, what comes next?
Or one.
61.1, the angle, right? Always the trig ratio, then the angle, equals what over what this time?
16 over X.
Put a 1 under this. Somebody help me out and tell me what is the tangent of 61.1?
1.8114.
1
I have a
point,
single one.
1 point, say it one more time, 1.8?
1.8114.
I only showed it to
Now do you, it's 0.811496.
So-
Would you
I round
it to
Round that to 5.
I gotta go to school.
Now, if you don't round that to 5 and you leave it 4, that's 10 thousandths of a place out. Is it gonna make a whole lot of difference in your answer? Probably not a whole lot, not enough, especially if the sides are only 13. Now, if your side was like, 65,000 on one side and whatever else on another side, then it might make, it would look like a big difference. It'd be like 20 or 30 difference, but not that much.
I was building a satellite in that.
Well, yeah, if you're, but for this class, we're not being real precise. Probably, you wouldn't even rounding that 5 up, if you're building a satellite, it's not gonna be close enough. You wanna keep it as an exact answer, and you'd have to go with,
You round
instead of this, you'd use the radical form of the tangent, sine, and cosine, which we haven't really covered a whole lot about.
I don't think they use weird things like that though in satellites. I don't think they use like crazy
They use lasers.
0.00001 angle.
So you think everything in life comes out where it's all nice and even, and so
That's how I do
we'll
it.
make this angle 20 degrees, and then this side's gonna be 10.
Oh, Josh, what if
Stuff in
that
life don't
angle
work out that way.
makes, like if you're docking
The
the
smallest
space
gap.
shuttle, that smallest little thing, and then all of a sudden everything's ruined, and then Sandra Bullock does.
I would
Make that
laugh.
cube space or both colors.
So like you say, you dock, and you say, okay, we're docked, and then you open up the door, and you're letting space in, and all of a sudden all the astronauts are burning,
Close that door.
skin peeling
Take all
off.
the space.
First of all, you don't hear them in space. Second of all, it would be like, they wouldn't suffer, they'd just instantly blow up and implode on themselves.
Wait, they wouldn't freeze up?
No, right, they'd all be sitting around on the couch,
in the
they'd
sun.
be yelling at Josh like,
They burn
"Hey,
from the
close
inside,
door."
and that would-
No, they just like their
Makes
body, like all the vacuum of space gets inside of them and they.
I thought, yeah, I was gonna say that's what.
You're
It
in
does
there.
make sense.
Right,
Yes, it
right,
does.
yeah.
Watch it.
I was
Go
doing
into
Neil
space.
Armstrong, okay?
All right, back to math.
Die.
The Neil Armstrong like that.
We cross multiply and you get 13 equals 1.8. Back to math. 18115x. Now what do we do?
You divide each side by 1.8.
Sorry, I wrote my number wrong. What's x end up being this time?
7.1763.
7.17. So we'll say 7.2. So this side right here is 7.2. Have we found everything? Have we solved the whole triangle? Still got to find the hypotenuse. Now, a couple different ways you could do this. I'll let you guys choose. We know two of the sides now. So if you know two sides in a right triangle, you could always use what? Pythagorean's theorem. So we could use Pythagorean's theorem, or we could use one of the sine, cosine, tangent, and find that side also setting up another equation. Which one you want? You'd rather do this again?
Yeah.
Right. So, are we going to deal with the same angle again?
No.
You want to deal with this one this time?
Yeah.
All right, so we'll
Mix it up.
mix it up, do that. If we do that, then that means we got to change. This is no longer the opposite side. What is it? That's the adjacent, and this over here is the opposite. We care about the hypotenuse this time. Which one of these two do you want to use?
7.2.
7.2. See, Brian's got to try to pick the hardest one, because I would have picked the 13 because it's a whole number. Which trig ratio deals with opposite and hypotenuse? So we do sine of, what's our angle that we picked this time? 28.9 equals what over what? Over x or y. Let's call it y this time, just so I don't confuse anybody with that, huh? Yeah, as soon as I put x over there, everybody's going to think it's the same x, and we don't want to do that. Put a 1 underneath this. A lot of you, and just to make this easier on you, if you can do it this way, you find the side of that. Somebody help me out. What is that?
0.4832.
Just think it through in your head, because in no way, shape, or form do I ever write all this stuff out every time when I do one of these problems. I'm showing you to do it that way if you're getting mixed up at all, you write it out and it'll be easier for you so you don't get mixed up. If I was doing this problem, I look at this and I cross multiply, and I know in my head that 1 times 7.2 is 7.2. This times y, well, that tells me what do I have to do with this number? You're going to divide by that number, right? So I'm just going to take this other number over here and divide it by that. So use your calculator, do that instead of me writing it all out every time. Now, if that confused you at all, then should you go through the steps and write it down so you don't get confused? Yeah. And make sure you don't make careless mistakes. Faith over there is going to think, oh, I'll just do it that way out every time, and then she gets confused and she's going to blame it on me because she missed every problem because she didn't work it out all the way through. What'd you get?
14.9.
Let's go back and look at these sides real quick. If my pen ever writes. 14.
We just take the 14.8.
14.8. You got 0.8 or 0.9?
It comes out to 4.900.
My paper is 14.8, but I forgot to round.
It's 14.9006.
835.
Now,
I got 8.
what might have happened, if you use this angle over here, might it give you just that little bit of a different answer? Yeah. So some of you got 14.90, others got 14.83 said. Well, you're like 7/100ths off from each other. That's probably not too
It's
bad.
gonna make a big difference when your satellite is trying to dock with a space station.
Josh, I'm gonna stay you out in the hallway here. Did we solve the whole triangle?
Yes.
Yeah, we found,
On the test, what if we have 14.9 and 14.8?
I'll know this.
He's not gonna count you off for like.
We got all three angles. We got all three sides. Now let's look at our sides and make sure that they make sense. First, our angles, they make sense, right? Because none of them are real small, none of them are bigger than 90. On our sides, are those sides sensible for a right triangle?
Yeah.
What's one thing you should look at probably?
If the two legs add up more than the hypotenuse.
All right, these two should add up to be more than the hypotenuse, do they?
Yep.
And the hypotenuse should be the
Biggest.
longest, is it?
No.
So you can check stuff like that to make sure your answer makes sense as far as the math goes.